Go ahead. Hi and welcome everyone at today's AI 42 session where we welcome Henk Bowman, from Microsoft. And he recently joined Microsoft, and before that he was an MVP as well, right, Henk? Do I say it
Yes,
correctly?
absolutely. It is already 2.5 years ago that he joined Microsoft.
Oh, then it was not that recent. For me, it's always like it was yesterday. It's always like it was a big thing that I remember now.
Yeah, still the same. Same for me. It feels like I joined yesterday, but time goes
Yes.
fast.
Yes.
Yes,
We've
and
seen
now you're here
you.
with us.
Yes,
Go ahead,
I made
Henk.
it.
Yeah, so we've seen you around at quite a lot of conferences and meetups, Henk. Can you tell us a little bit about some of the different venues where people can see you?
Yes. So for these coming months, fingers crossed if all is going to go through, but that will be in NDC Porto. That will be really great. That was like the conference I was going to, and then COVID happened and everything got cancelled. So I'm really happy to be back there. One other event I want to call out is the Scottish Summit. That is going to be actually, I think, on my birthday on 10th and 11th of June, which is going to be great. I think we're going to meet so many speakers and so many interesting people there, and so many sessions to learn from. And then finally, NDC London in May. So it will be good to be back in London. Looking forward to that. That NDC London was actually my first tech conference I ever attended. So now after 5 years, I'm actually speaking there. So I'm really happy.
Oh, nice memories and everything.
Yes.
That sounds cool. And I am really happy that we can welcome you today at AI 42. And we are going to, you will talk about how to work with DevOps and Azure Machine Learning.
Exactly. I will show you how to kind of make an Azure Machine Learning pipeline using Azure Machine Learning and the new CLI tooling that we have.
Ooh, that's very exciting. I really like that part when you're like doing magic with the CLI or PowerShell or something.
Yeah, we will
All
not
right.
dive into DevOps, but basically because everything translates to CLI comments, it is really easy to automate in GitHub Actions, in Azure DevOps, or in any other tooling.
That sounds really exciting. Before I give you the stage, let us give a quick introduction to AI 42. See you soon.
Yes, so welcome everyone to AI 42, and I'm going to tell you a little bit here about the background and motivation to AI 42. So the motivation here comes from the recognition that there is really no good starting material for getting into machine learning and AI. So what we wanted to create something that can take you, from A to Z. So AI 42, we are a strong team consisting of 3 Microsoft AI MPs. So it's me, Eve, and Gosia. And we strive to provide you with a very valuable series of lectures that will help you to jumpstart your career in data science and artificial intelligence. And the way that we do this is we provide you with the necessary know-how, so that will help you to land your dream job as long as it's related to data science and machine learning. And the concept is quite simple. Basically what it is that we involve professionals from all around the globe that will explain to you the underlying mathematics, the statistics, the probability calculations, data science, and also machine learning techniques. And this might sound like a lot, but don't worry, because we will guide you through all of this. So all you have to do is to follow our channel and enjoy the content that we will provide to you every second week. So this will be filled both with real life cases and also expert experiences. And everyone has started from scratch, so have we too, and we're very happy to help you to build up your knowledge from here. And you can always stop and rewind the videos and ask for clarification in the comment section, and we will answer you. And we hope to assist you on this wonderful journey and have you as a speaker here one day. And we believe that by creating cross collaborations with other organizations, we can give you the best opportunities to broaden your network in the AI and data science communities. And with the combination of our offered services, we would support less fortunate people and organizations that are not that recognized yet, even though they deserve it.
Our organization is sponsored by Microsoft and Miles, and we are also humbled by all the support we get from our contributors as well. So thank you, Levente Pongor, for all the beautiful graphical content, and Mina Murray for the cool intro music before our event. We are also in close collaboration with C# Corner and Global AI Community, so our lectures are going to be available on their YouTube channel additionally to our own media. And Nicolette Todt creates and reviews all our text content we use on our website, advertisements, and during our sessions. So go ahead and follow us on Facebook, Instagram, and Twitter to become part of a growing community where we will share knowledge and fun. You'll find every information that will bring you to an advanced level in the field of data science and AI. Watch our recorded sessions on YouTube, and you can find our upcoming sessions information on our meetup page.
Yes, and one thing that we think is really important here is to provide a safe environment here. So we have our code of conduct that outlines the expectations for participation in our community, as well as the steps needed to take in order to report unacceptable behavior. And we are committed to providing a welcoming and inspiring community for everyone. So be friendly, be patient, be welcoming, and also be respectful with each other. And you can see our full code of conduct on this link. So then I say that let's get back here to Henk.
Yes. Hi, welcome back, Henk.
Hi, thank you. That was a good introduction and a really good initiative.
Thank you so much for that feedback. It's always nice to hear something like that. All right, I think it is time to give you actually the word, if you're ready.
Perfect. I'm always ready.
Cool, then the stage is yours.
Perfect. Thank you so much for this introduction. And hi, everyone. Welcome to my session, How to Build an Azure Machine Learning Pipeline. So my name is Henk Bohlman, Cloud Advocate at Microsoft. You can follow me on Twitter. All the demos and everything I'm going to show you is available on my GitHub. And there are a lot of articles that go a little bit more in depth about what I'm going to tell you today on my blog, henkbohlman.com. So what are we going to cover in this session? We're going to look at Azure Machine Learning. We're going to train a classification model, then convert that kind of development model, like from a Jupyter notebook, to an Azure Machine Learning pipeline, and finally deploy the models to a managed endpoint. So I don't have much slides, so today will mostly be demos. But I have this slide to start with to answer the question, what is Azure Machine Learning Service or Machine Learning Studio or Machine Learning Studio? So in short, we call it Azure Machine Learning. But basically, it is a set of Azure Cloud Services that can be controlled with a Python SDK and the Azure CLI, and we will cover them both. And that set of cloud services enables us to prepare data, train models, track experiments, and finally deploy it. And when I talk about a set of cloud services, I'm talking about the Azure Machine Learning service itself, but also the underlying blob storage, container images, the compute. So all these things, all these Azure services, they work together and create Azure Machine Learning. So I'm not going to talk much more about that, and I'm just going to show you Azure Machine Learning Studio. So this is my Azure Machine Learning Studio. You can create it in the portal by going to create new resource, Azure Machine Learning, and it will create all these resources with you, for you. So it will create the blob storage, the container registry, all those dependent services it will create for you at once. And then you can access it by going to ml.azure.com. You log in with your Azure credentials, and then you will get this interface. So let me walk through the menu so you have an idea what the capabilities are. So here I'm in my dashboard. I can start and create everything new, like notebooks, pipelines, and so on. I can do everything in the interface. I can here go to my notebooks, can do automated machine learning, and I can use the designer. And the designer is this really cool drag and drop interface where you can connect all these steps and create your models like kind of in a visual way. So we have notebooks, automated machine learning, and designer. So these tools and these interfaces will kind of help you create the best model. But if you want to do it yourself, you can use all these components controlled by the SDK or by the CLI. So first we need data. So here I have all my data sets, and they're all stored on this blob storage. So we are going to use a data set with Lego Simpsons figures to create actually a quick classification model. I can explore this data set by looking at all the files that are there. It is now just connecting to my blob storage and just loading all the images from there. So what is it here? This Aunt May. So kind of these Lego figures are in there. There are also Simpsons in there. So basically this data set consists of, I think, 13, 14 classes with around 30 to 50 images per class each. It tells you how you can consume it. It will give some code snippets for you. And it, of course, points you to the right documentation straight from here. And the cool thing is that you can have a data set, and the data set can have different versions. And that is really handy because later on you can actually go back and see, oh, I used version 2 of this data set, and there was a fault in it, and that is why my model is actually not doing the right thing. So let's go to experiments. Under experiments, we keep track of all the training runs. So every time we train a model, log files are generated, artifacts are generated, and they're stored under an experiment. Components are reusable components that you can use in, for instance, pipelines. We're going to create a few later on. Pipelines are the pipelines that you can create. They all consist of different steps that consist of components again. Under models, you can register your model. So every run will generate an artifact that is actually the model, and you can register that model in model management. And I always see it like kind of the NuGet repository for models. So you check a model in, you say this is the Simpsons classification version 10. So anyone can pull out that model, say give me Simpsons classification version 10, and build software around it. And the model with that software around it, we can actually deploy into a few different endpoints. So we have here real-time endpoints and batch endpoints. So we can deploy our models there. We also can deploy them to Azure Container Instances. So we will close off the presentation with actually doing that. So these are our assets. And then we have some things to manage our infrastructure. So we have compute. We have compute instances. Compute instances are used to run our Jupyter notebooks, for instance. They are very small compute containers. Yeah. Then there are compute clusters, and these clusters are used to do our training on scale. So I have two clusters here. I have Optimus Prime and I have Bumblebee. So Optimus Prime is a cluster that consists of standard NC6 machines. We can click on it and can see what this standard NC6 means. These are machines with 6 cores, 56 gigabytes of memory, 380 gigabytes of disk, and the most important thing, it has a GPU in it. It also displays the cost for you, but sometimes you don't need a GPU to train your models. And then I have this other cluster that consists of way cheaper virtual machines that cost a lot less. So here we can see it, and these are only 5 cents an hour per node. So you don't always need the big machines, but it will definitely speed up things, especially for our case today. Then we have data stores. These are the connections to where our data actually is. I'm using just the default blob storage. And then there is a data labeling services, and you can link other Azure services to your Azure Machine Learning Studio. So that is a very quick introduction about what all is capable. So let's start and build a model. So I'm going to use a GitHub code space for that, because all the training is being done in Azure Machine Learning. So I can actually use this GitHub code space to do it. So I've created a configuration that installed all these kind of things for me, installed the Azure ML Workspace plugin, I installed the Azure CLI in it, and everything is here in this dev container folder, which tells me what is all installed. And here's actually the Docker file that will create this development container for me. Every time someone goes to this repository and says, give me a code space, it will build this kind of development environment for me. And it saves so much hassle for me, because I don't need to configure all these different types of Python versions, Azure ML versions, Azure CLI on my machine. I can just go here, open an interface that looks exactly the same as Visual Studio Code, and work safely from the cloud. I can just go to any other laptop, click, and I have my development environment up and running for me. So that is what we are going to use. So I have a Jupyter notebook, and like you see, it works exactly like you would expect it to run. I can have different kernels here. So I'm going to use this one. But you can install all the things like you would install there. Is there a cost for using code spaces? There is a small cost for using code spaces, and your organization has to enable code spaces on GitHub. So I will start with importing a lot of dependencies, because I would like to put them in the first cell, and then my code looks a little bit cleaner, but everyone has his or her preference for that. I'll try to zoom in a little bit more so you can see it a little bit better. So the first thing I need to do now is connect from my code space to my workspace. So I'm going to use the Azure CLI authentication, and I'm saying workspace, connect to my workspace called Cybertron and the resource group Cybertron with this subscription ID, and I'm using the CLI authentication. Let me run it. Let's hope it actually works. Perfect, it's working. Then I'm going to connect to the compute I'm going to use, in this case Optimus Prime, to my default data store where my Simpsons images are stored on, and to my experiments called Simpsons PyTorch. And here we see I'm connected to the workspace, connected to the compute target data store and experiments. So now we're going to do some remote training. I am going to connect to my dataset, in which we just saw Lego Simpsons version 1. So I can just say dataset, get by name, give the workspace, and then say Lego. I can also configure the version number, or I can give it as a parameter, but I'm not going to do that now. So this command will actually give me the latest data set. I'm connecting to that data set. And now we have data, we have compute. We need to have an environment where it is going to run in. Because what happens underwater is it will pick up a container and it will deploy that to my compute cluster. And inside that container, my training scripts are going to run. So you can do that in two ways. You can create your own kind of environment, but sometimes it is easier to pick out a curated environment. And because we are going to use a very basic example from the PyTorch website, we can just use a basic PyTorch image. So this is the name. So I'm going to use an Azure Machine Learning PyTorch base image version 1.10 running on Ubuntu, and that is enabled for a GPU use. I'm going to create it and I'm going to clone that environment. And I give it the name PyTorch Simpsons Training. So next, I have to configure how this script is going to run in that environment.
Yes, Henk, we got actually a couple of questions here. So we got one question from Ashish, who asks, is Codespaces available for everyone?
Yeah, I saw the question, and I actually don't know what the status is at the moment. I knew a few months ago it was not available for everyone. So your organization or someone has to enable the use of that.
Okay. And we also have a question here from Kevin, who says, can you use the same dev container template being used for the workspace for running VS Code in a container?
That I don't think so. You can create a dev container where VS Code is going to connect to. So we have some workspace, some workshops for the Global AI Bootcamp that is actually using a dev container. So the development container is running in Azure, and you're running locally Visual Studio Code, and you connect your Visual Studio Code to that container. So everything you do is happening in that container, but your interface is still there. So I don't think you can get like the actual interface available to a web URL in that container, but you have the container to develop your resources or your code in.
Okay. And we also have one more question here from Ashish, who says, the dev container, can it be Windows container?
I always use the Linux container so far.
Okay, thank you so much.
Cool. So where were we? We were here. Like we have our environment that is going to deploy to our compute cluster. So now we have to configure how our training script is going to run in that environment. So let's take a look at our training script. So first we have to specify a source directory. So we're going to go to scripts, train, and we're going to click on the training file. So this is the default transfer learning classification example from the PyTorch website. I copied and pasted it, and I added a few things to it so it works on Azure Machine Learning. So I added these references so that I can connect to the run and to the workspace and get actually the context of where my job is running in, and that I could parse incoming arguments. So here I'm parsing some incoming arguments. We transfer and prepare our data set, and then we start training the model. And in that training group, I added some logging. So I added run.log. So it is actually logging the accuracy and the loss for every iteration of the model. And that will, because it detects that it is a float, it will automatically start drawing some graphs. Finally, I'm logging the final accuracy for the best accuracy that it had. And I write the labels, and I save the models in an output folder. Because this is being deployed on the cluster in a container, it will shut down when it is done training, and then everything is gone. So everything you want to have saved, all the artifacts you want to have saved, you can save in the outputs folder, and that folder is automatically copied over back to your experiment from where you can access these files. So that are the only things I've added. So I'm specifying here the incoming arguments. I'm connecting to our data set. So this is the Simpsons data set that we just saw. I give it a name, and then I'm mounting it. So now my data is available as a virtual directory in that container. And the link to that virtual directory is in this variable. Specifying the training script, which compute target it has to run, which environment it has to use, and which arguments it has to parse into. So let's submit that and see what is going on. I already had like a few nodes up and running, so we don't have to wait for my cluster to spin up. It should already start training very soon. So we say run submit, and then with this widget, with run details, we can actually see real time what is going on. So this job is now in scheduling state. Then it gets into like queued, and then it will actually start. So while we wait for that, I want to quickly illustrate what is going on underwater. So from my Azure Notebook, Jupyter Notebook, from wherever you call the CLI, you say submit. And at that moment, it snapshots your folder with your training scripts and everything and copies that over to the experiment. From there, it is going to create a Docker image from the environment specifications and deploying that Docker images with your snapshot to the compute instance. Then it mounts your data stores, basically your data set, but that is always located on a data store, into that container, and then it launches your training script, train.py in this case. And then all the details and everything that training script and your container generates is being sent back to your experiment. And with that widget, you can actually see that data real time. When your training script is done, it quickly copies over everything that is in the outputs folder, and then it shuts down. So let's see if this is actually running. It is still in scheduling state, so that is weird. It should be finalizing. Yeah. So one is finalizing, and our job is complete. So we can dive into the different logs, which we're not seeing here. So I will go actually to the experiment in here in Azure Machine Learning. Click on there, and then we automatically land in the job. We see the final accuracy was 0.99, which was pretty good. It took it only 1 minute, so that is pretty fast. Trained on our compute cluster, Optimus Prime, used our Lego data set here. These were the variables that were being parsed. It is the underlying GitHub repository, underlying Git commit even, so you can actually go to GitHub and see which commit from the code was being used. And these are the metrics that are being generated by that run.log comment that I just added to our training script. So we can see the training accuracy, the validation accuracy, the validation loss, and the final accuracy here. There are no images, there are no childrens here. And here is all the log file. So this is the log file that actually is being generated by the output of my training script. Oh, and I should upgrade something again, as always. So I will do that next time. And finally, we will see here the generated model. Here we see the different classes, and we see the model file that is being generated by our training script. So this is super cool, because now we have a model. And we now quickly want to register that model. So we will register that model on the Simpsons classification, and that is number 11. Let's do it like this, so you all see that it is our model. We go back to Azure Machine Learning. We go to models. We see here version 12. We can click on it, see Conference AI 42, version 12. And here we see with Experimenter, which is run and generated, so we can track back everything. Now let's test it and deploy this model to a Azure container instance. I will quickly run it and then tell what it is. So everything starts again with an environment where this model has to run. And so for this one, I'm going to create my own environment because I want to have full control over what is in my container. So I'm going to name it Simpsons Inference, install these 4 packages, and that's it. I have a scoring script, and what that scoring script is doing is just loading the model, loading the labels, getting the input data and scale it to the right tensor, and then run that through the model and return the prediction for me in JSON. There are 2 methods here. There is a run method and there is an init method. In the init method, you load your model because loading models takes time, and your run is being executed every time a request comes in. So that is that. And back to our deployment. So we now have our scoring file and our environment. We bind them together in an inference config, and now we can create a deployment config that will specify how many cores and how much memory we have to use. We combine that in a deployment. So we name the deployment Simpsons classification test. We have the model, the inference config, the deployment config, and we specify that it can be overwritten. So it is here deploying, and here you see it is deployed. So within, 16 seconds or something, it's 26 seconds, it deployed that model in my environment to that endpoint. So now we can actually test it with some test images, and we see that it is predicting Bart Simpson on this image, and it is actually Bart Simpson. I can show you what happens if we run Lisa. Here is Lisa, and here we see that it is actually Lisa. So our model works, but do we really have the best model? So we can optimize this model using something like automated hyperparameter tuning. And what that does is it samples our input parameters for us. In my case, it does it randomly and runs all these training things, these training rounds next to each other, and gives us finally the best metrics. So I already have that, but we can quickly run it because it shouldn't take that much time to actually do it. So while it is running, let me go through this configuration file. We start with the same data set, exactly the same environment, but instead of having a script run configuration, we have a hyperdrive configuration, meaning that this is basically the same as that we used up. But now we're going to sample these additional input parameters in the script because we have them as parameters in the script. So what do we say? We say the hyperdrive config use this script run configuration, train.py, same compute target, same environment, same arguments. Use these sample parameters up here. Then we're going to look for the best accuracy. So our primary metric goal is to maximize the accuracy. You can total have 4 runs and run those 4 next to each other. You can scale that up, but then of course you need more compute and more compute instances. So it is actually running. So let's see what is going on. It is running. Some things are being queued, but this widget was not working that good. So let's see what is going on here. Do we already have some metrics? No. So it is still waiting for it to be here. You see our jobs are being scheduled. And here we see that, okay, it sampled kind of the right number of training rounds, but the learning rate and the momentum, it took some random values. So in a little bit, we should be able to see it. So in the meantime, I have this one slide that should explain why this is a cool thing to actually have. So we have a data set, we have different training algorithms, and we have all these different parameters, and a combination of them will give us the best model. So in the old days, before this was a thing, you had to train all those things manually. And that is like, basically, I don't think it's very time consuming. Absolutely. And I don't think it is the most fun to change all these parameters by hand. So this is actually quite a handy tool to find and fine-tune your model for the best accuracy. I hope I talked enough and that it is actually here. So 1 is running. So basically 4 should have been running now. So let's refresh this and see. Yep. So all these 4 experiments has been run now. And here we see the output of the final accuracy from the different runs. So we can say that the Witty Lizard run gave us the best accuracy. And here we can see and follow these lines to like, okay, so with this hyperparameter, we actually get the best result. So now this thing has child runs, and a child run is exactly the same as one of the runs we've seen before, but now it is a child of that hyperparameter run, of that hyperdrive run. So this is all super cool. Now we have basically a good model. We know the parameters, we know everything what we have to do, but it is still in a Jupyter notebook. And now the step comes, how can we automate it? How can we create a pipeline that will do that for us and we can actually start using in production? So for that, we are going to use the Azure CLI for machine learning, the vNext extension or V2 extension, whatever you want to call it. So this is an extension that you install within the Azure CLI. So then that is the Azure client command line interface, which brings us back to like a command prompt you see here on the screen, where we can just type cool comments. But we are not going to type comments. No, we're actually going to use Visual Studio Code to help us generate these configuration files for us, which we can give to the Azure CLI. So we don't have to type like these massive amounts of lines. And we want to have some auto-completion in those things. So, and that is what the plugin for Visual Studio Code does for us. So this is also Visual Studio Code. So what we can do here, we can go to Azure. Here we see all my, let's go to my workspace. Azure, where is my machine learning workspace interface? I probably reboot it again. Yes. So can I now go to my work? Installed. Probably here. Yes. Okay, this is how it worked. Now I find. So here I actually have all the same things. So I have my data sets, I have my experiments, I have here all the Simpsons PyTorch, here I have all the runs, I can access the logs. So I can actually have all the same things I see visually in the ml.azure.com. I also have in Visual Studio code. So here we have all the completed runs. Lama VS cuts, then there's the pipelines. So these are the experiments. Here we have all the different models with all the different versions. So you can see that. But the cool thing is that you can right click on it and you say create a data set, and it will generate some YAML for you. So let's, if I say here that is like test, I can now say execute YAML, save, test. Save it here, please. And it will execute this YAML file for us here. So this is obviously not a directory, but it can create it. We have a directory here with actually yes /data. Execute it. So we say Azure Machine Learning, create a data set. It is now uploading all the data for me here. And we should be able to have that data set now here. You see it is just created. Now this is CIT, files in a data set, 545. So what we can do is we can use Visual Studio Code to help us generate these configuration files. And this Visual Studio Code plugin has context about our Azure Machine Learning workspace. And that is pretty handy if we want to go to a, this is the prototyping, so the training pipeline here. Like if we want to use some data sets. So here we can say, use a Lego V1 dataset, and you saw it just loads my data sets in from there. It can also do that with environments and all the other kind of things. So that is really handy to create these YAML configuration files. A very good thing to know about these configuration files is in the Jupyter Notebook, we use Python code to actually train the model, but also to control Azure Machine Learning, Azure Machine Learning Studio. And now we have the configuration files that configure how your training script has to run, your code has to run. So these two are now separated, which I think is a really good idea, because now you can focus on your training script and someone can focus on Azure Machine Learning and configure more how that script is going to run. So this is a pipeline, and I will actually run it now because it takes a while. And we just update it to use our data set. So let's have a look at this pipeline. So what a pipeline is, it are a lot of different jobs which can share the output from the previous job. So we are going to create a job that is going to train the model and then register the model, register the PyTorch model, kicks off a script that will convert that PyTorch model to an Onyx model and registers that Onyx model also in Azure Machine Learning. So a very, very basic pipeline, but it will in the end will give us two different flavors of models we can use. So let's start it. So I'm specifying it is a pipeline, and this is the schema. I'm telling it to use the compute Optimus Prime. This should actually also you see, also autocomplete. This pipeline YAML will only work with Azure ML Studio. Yeah, so this will work with Azure CLI and will be executed by the Azure Machine Learning Studio. Yes. So we're specifying some settings. Use the data store and the works blob, the workspace blob, the default one. These are the inputs, the training data. And we're using the Lego Statesman's data set. And then we start configuring our jobs. So first job is train the model. register PyTorch model, convert it to Onyx, and then register. But these steps will start running in parallel because we don't really have to wait. Then finally, we register the Onyx model. So here we reference and point to different components. So these components are reusable things because here you see I have a register component that will take a model in, take a model name, take a model file, and will actually do the registration for us. So I don't have to write separate things. So you can make these models kind of reusable. You register and then everyone can use them, or you can kind of keep them for yourself, what I'm doing in this example. So here we have our model. So let's look at the train model, because we saw we had that script configuration run in the notebook. So this is the translation of that in YAML. So here the step name is called train model. It is going to train a PyTorch classification model. These are all our input parameters. This is the output. So that is just a path on our storage where it is going to put it. This is where the code is in source. Here, train.py. Same thing, the environment. And then we type the type Python command this thing has to execute. So we say Python train and give it all the input parameters. So this you can really try on your own machine also to see if it is working, your script. So these are the default values, and you can of course overrule that in your pipeline. Registering is very simple. It comes in, we have the model name, the file, and actually if there is a label file, because some models need that. And then we just say Python register, give them all the input. And what this step does is just doing a register of it, upload it, and so on. This is all available on GitHub to dive in depth in these scripts. So we have these components, we give it the input, but here you see that this generates train output, which is specified. It is the output that gives the training outputs, and then we can actually use that output from the jobs, the train model step, the output, the train output, and then use that as an input for the next step. So here we see we use that output from this first step in these two other steps. So that is kind of it. But now, because we have these different steps, you can really make your code optimized for that step. So your code doesn't get like too long. It doesn't include and register and convert and so on. So that makes it a little bit better and a little bit better maintainable. So cool. Let's have a look if this pipeline is actually running. And of course, I have to log in. Yeah, no two-factor. So that is perfect. So here our model is running. So now we get this really cool visualization of what we were actually building. So here we have our data set. This is the training script that is actually using the exact same train.py as what we saw in our Jupyter notebook. And here we see that it's taking in the model assets paths to the training output in this variable and the training output in the input assets path here. This done training, and if you click on it, you actually get, again, the same thing as that we saw from the script run configuration. You see that it took 53 seconds, which compute target, the actual command that is being used, the data set, the output, the environment. Here we can read all the logs for that step. So everything is there. So it is now registering it. Let me see what we can do here. If it is registered, if you can see anything here. the input. No, it doesn't show where it is registered. Here that is converting it to PyTorch. That is done, and then to Onyx, sorry, and it is registering that here. So now we should be able to see here the syntax classification PyTorch. That is register model from the pipeline, just 12 minutes before time. And let's wait. We should be able to see in a few minutes the Onyx model converting, registering. You can do it. You can do it. So all these pipelines are available now from a pipeline. Here you see this one is actually run. You can update these pipelines. You can publish these pipelines. So if you publish this pipeline, you can actually call this pipeline with an API call. But for building this pipeline, now it has downscaled to actually just one Azure CLI command. And this Azure CLI command you can run in any continuous integration system. You can use Azure DevOps to run this for you. You can use GitHub Actions by just calling this Azure CLI command with this configuration file. So I think that is really powerful and gives you like so much flexibility in how you would build or deploy your models. Still running. Okay, I know it is kind of hard and heavy to register an Onyx model, but it will come. So the last thing I want to dive into is how we can deploy these models. We've seen we can deploy this model to an Azure container instance just quickly for testing, but that is not something you want to have in a real production scenario. So that is why we have online managed endpoints. So we have, can you perform hyperparameter tuning during the pipeline? Absolutely, you can do that. So you have a client, hits the endpoint, and in that endpoint, there are multiple deployments. So I have version 1 of my model, version 2 of my model. I can deploy that in the same endpoint. So my endpoint is hanksmodel.azureendpoints.com or something. So that URL always stays the same, but the traffic manager then will route probably 90% to one model and 10% to the other model. And I just have sliders to control that traffic, but you can also do that again using the Azure CLI. And the cool thing about these deployments is that those deployments in that endpoint can have auto scaling, and you can choose to compute where they want to run them. So you can deploy like model 1 on like CPU enabled machines, deploy model 2 on GPU enabled machines, and then in Azure Machine Learning, you can actually see the metrics for that endpoint and see which one is performing better. And then you flip over all the traffic, delete the deployment, and then you can deploy the next version of your model. So I have already done that. I've deployed the PyTorch version and the Onyx version in one of those endpoints. So if we go to endpoints, we should be able to see where is my managed endpoint. Here is my Simpsons classification. So here we see my two deployments. I have an Onyx model and I have my PyTorch deployment in there. That is actually the same configuration as that we saw for the Azure Container instance. And I'm routing the traffic to 50 to 50%. So here we can update the traffic. We can say run 100% there and so on. But now we're going to do basically a round robin. So here we see my running from Onyx 2 score.script, this type of compute. In one instance, I don't have auto scaling enabled. It is just one thing, but we can go to the metrics. We can actually monitor them here. There is not much traffic going on at the moment. So we show for the last 24 hours. Let's put it to the last 3 hours. Actually, we can put it for the last hour. So we should be able to see some of our incoming requests here and what time it takes. Here we can actually see the deployment logs, like did it actually go did it actually go well, or didn't it go that well? We can test the two deployments separately from here by specifying the input JSON it needs, and some Swagger things. And this is actually the REST endpoint. Yeah, I could not remember that. But what I have here is actually a test that will call that endpoint to the score method. There is a security token on it, and it will post these images. So I'm going to start sending requests. And the cool thing is that it now is telling me, hey, you hit the model deployment Onyx. And here is the PyTorch one, the Onyx one, the PyTorch one. So I'll click a few times and I hope it will generate some statistic for us, but the statistics are like a little bit behind, so I hope we will see it. So we'll keep clicking for a little bit for it to wake up. So then we should actually see it here. Hopefully I'm monitoring. Not yet, so that will the last 5 minutes. It is always like a little bit behind the logging. So here we actually should see the requests coming in. Here we see the request coming in from my VS Code REST client 1655. It's converted to UTC. So this is actually my request. So now, okay, we'll have to wait a little bit for this one. But managed endpoints, really, really nice to deploy your models in such a way that it can be scaling and so on. Can we deploy ML Studio in a private Azure Virtual Network? Absolutely. Yes. There is a lot you can do with Azure Machine Learning. And especially with the type of compute you can deploy in your own virtual networks. So, and that brings us to the end. All this code is available on my GitHub. github.com/henk/Azure Machine Learning, PyTorch/VS Code, where you can just pick up these things, these components, and play for yourself with your own data sets. I can take some more questions probably. We have 3 minutes left. So, are there any?
Hi, Hank. That was amazing. Thank you so much for this cool demo and all the information that you shared with us was really valuable. There is one thing I would like to ask you to do. Could you post the link for your GitHub to our chat so we can share it to the stream?
I will do that now.
Thank you.
And we also got some more questions and some comments here. So we got a question here from Ashish, who says, where is all the data for Azure ML Studio backend stored?
If they mean with backend the log files and so on your runs are generating, that is all stored on your workspace blob storage.
Okay. And some comments here from Gabriel, who says, very cool demo, nice explained, Hank. Thank you so much.
You're welcome.
And we have a question as well.
Okay, yes.
From Kevin.
Yeah, so Kevin says, can the compute hosting the managed endpoint be upgraded while staying online?
Yeah, that is a good question. I don't think your deployment you can upgrade, but what I would do is I would just deploy a second deployment in there with the upgraded compute, spin it up, see if it works, and then route all the traffic to that deployment and then throw the other one away.
Okay. And some more question from Gabriel. Could you please elaborate a bit on how the data labeling process works? Is it manual?
Okay, so for me it was manual, but we have the data labeling service, which it should. I just don't know. I never used it. If it is automatic or normal, I know. For instance, the computer vision service will give you hints after a while. If you have like your first model, then it will just kind of, oh, this is this one, this is this one, this is this one. You just have to confirm. But I have no idea how this thing works in Azure Machine Learning Studio at the moment. Did any of you try it?
That's what I was smiling as well, because I'm also normally writing my own code even on Azure Machine Learning, and the data processing I did like ages ago when we did the pipeline and do some data transformation and some cleaning and whatnot in the pipeline. That was the possibility, but labeling I haven't tried that.
No, yeah, there is this whole labeling service, but it's a good thing. I absolutely should take a look at it.
Yeah, I think it's a good idea. That always from these questions we get some ideas. We should try that out actually.
Yeah, more questions here from Ashish. How much approximately does this kind of ML Studio setup with pipelines and deployment will cost for an average dev or cloud user?
Yeah, that is a really hard question, because the costs is in the virtual machines you choose to use. They're very cheap virtual machines. To do that, your training might take longer. If you have a model that will needs like GPUs and trains like for 30 days, then it is more expensive. If you train like a quick model like I did, I just have to pay. So it was like $1 an hour for my GPU machine, trains in 5 minutes. Cluster adds like 5 minutes before, 5 minutes after, because there's the build up. You pay 25 cents for training my model if you use that. But if you're like me now and you leave your 4 machines on and you go to dinner after this and you forget to shut them down, it is getting really expensive. So there is the training aspect. There is also the aspect, how much data do you have? Because of course you pay for the data that is on your blob storage. And you pay for your compute in your managed endpoints, I assume. So that depends on which type of virtual machine you choose for there.
Thank you, Henk. And also, thank you for the great questions. I love this audience. They always have amazing questions. All right. Are there any more questions or comments we should visit?
No, I think yeah, we have one more question, which is actually not related to machine learning, but still it's an interesting question. It's this question. So this question is from Sarosh, who says, "What camera do you have, Henk? It is really clear and sharp."
Oh, that's good. So my internet is also good. So sharp cameras also need good internet, of course. So this is a Sony A4600. And the reason why I got it was that Jessica Dean wrote a blog about which setup to use for virtual events, and she recommended this camera, and her setup looked awesome. So if you go to my colleague's blog, Jessica Dean, he has an amazing blog about how to set it up with lights and which lens you need for your camera and which camera is actually good.
Yeah, nice. Yep, thank you so much. So Henk, if you don't mind, if you could stay a little bit, stay on the stream while we're closing, but we have some more information here from me and Eve.
Perfect.
Yes, and before doing so, Håkan, I want to say thank you again, Henk, for joining us to give this amazing speech.
Thank you for having me.
Sure. So thank you again for joining us tonight. It's amazing to see you always so active. It's very inspiring. And we come back in 2 weeks again with another session, which is with Johan, who is going to talk about how to build your lakehouse in Azure. This is going to be very interesting and exciting, and it is focusing on data storages.
Yes, and also we're always interested in having new sessions here. So we have an open CFP, a call for papers, and you can reach it on this URL sessionize.com/AI42. So feel free to post your sessions. You're very welcome.
And with that, we want to say a big thank you again for joining us. And remember, if you want to learn more or want to go deeper into what you just heard today, you're always welcome to revisit our YouTube channel, or you can find us on social media as well.
Yes. So with that said, I think we thank everyone, especially our speaker Henk, for a wonderful session, and also for our audience to be very active and asking really great questions.
Yes, thank you.
And look forward to see you in 2 weeks.
Precisely. See you soon.